Hey, Jonathan, welcome back.
Welcome back.
Yeah, I welcome you back. Hmm.
That's right. We're here for, I think, round three now. If that's,
Yes,
if I remember correctly. Yeah.
exactly. But
Yeah.
interesting story. So I attended a conference. So I delivered a keynote. But after the keynote, there were a few students, and they came to me and said, okay, they have an idea, a business idea, to
Mm.
to refactor or modernize old code to something new. And so I wanted to say something, and someone else came in and say, "Forget it. There is already OpenRewrite in place, so it's
Mm.
pointless." So I just wanted to say that it was actually, and the conference was a small one, and OpenRewrite was actually well known. So this was actually
Mm.
feedback to you. So
That's great to hear.
yeah, great to hear. And they were a bit sad, I had to say, the students, but maybe they can do something on top of OpenRewrite, right?
Well, that's right. I think there's plenty of opportunity to,
Yeah,
there's just a lot of different domains, modernization, security, et cetera.
sure.
And yeah, I mean, nobody can do it all. So,
Hmm.
a lot of element, a
Yeah,
lot
it's
of things to
just
do.
just fun. This is how it is. So today we have a small topic is Spinnaker and bigger topic is Micrometer, right?
Yes, 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 yes. Absolutely. They're
Yeah.
sort of related in a way,
Hmm.
um, but yeah, two good topics together.
Hmm. What I remember is a session at Java One, and it was about Spinnaker. And
Mm.
it was delivered by Google, interestingly, as I remember,
Yes,
two
yes, yes.
engineers. And so I took a look at that, and I couldn't understand back then why they need Spinnaker if we have Jenkins. So the relation between
Oh, yeah.
Jenkins and Spinnaker was not clear to me. And I used Docker a
Mm.
lot. And what I remember, what I did back then, Docker ran in Jenkins, and I used Jenkins to orchestrate Docker images. It was a crazy stuff like Meta,
Yeah,
but it worked
yeah,
well,
yeah,
and it was really, I mean, it worked. It was effortless. So actually, I hacked
yeah,
it on a weekend, and it worked for me. And then I saw Spinnaker, and I
yeah,
couldn't get the point. So, what was the idea, or maybe it even is, of Spinnaker?
yeah, absolutely. So, I mean, first of all, you weren't wrong to do that with Jenkins entirely. But I think Spinnaker was Netflix's second continuous delivery platform. So I used to, by the way, a little bit of background. I used to work on engineering tools at Netflix, but I worked on build tools. So really everything before the
Mhm.
Spinnaker process kicked off, and our sister team on engineering tools was the Spinnaker team. So I spent a lot of time nearby them. I think there's two main things. Spinnaker was not only it had a pipelines mechanism to do a deployment, whatever stages that involved, but it was also a stateful view of the current state of those assets in
Oh,
potentially multiple regions and multiple clouds together. So like I would describe a few nouns here. Spinnaker had these nouns: an instance, a server group, a cluster, a region, a cluster, an application. And so go through those one at a time. An instance, depending on the cloud provider that you were deploying to, or the type of, like if it's a infrastructure, if it's a regular VM based deployment, an instance would be like an EC2 instance. In the case of a Kubernetes cluster, it would be a pod. So this is like the concept of instance mapped to this cloud provider specific construct. And so yeah, a set of instances made up a server group. There could be multiple server groups in a cluster. The word cluster in Spinnaker did not map to typically to a cloud provider concept. You could
mhm.
have like multiple application server groups or in AWS that together represented a group of things. And those things would be like multiple versions of the same application where you could do a rollback from one to the other and so forth. And then an application is where things get interesting. So an application in Spinnaker is like roughly like a microservice,
Mhm.
but that microservice could be running potentially in multiple independent cloud providers. It's running in Azure, it's running in
Mhm.
AWS, it's running in GCP, it's running in a Kubernetes cluster. And when you are an owner of that microservice, you can basically look at the application there and you see the status of every instance in every server group in every cluster in every region in every cloud provider. And so it was in a sense like this generalization of what it means to run a microservice over, many different resources like that. And the benefit was really like multi-cloud continuous delivery of sorts, with that abstraction, if you could fit into that abstraction.
Makes sense.
The second major thing, so that's the stateful model of it. The second main thing versus when it comes to just the act of deployment, one of the characteristics of deployments can often be that you do a request to AWS asking for the provisioning of a new ASG, and you could wait for a significant period of time before AWS is able to satisfy that request. And in the case of running on a CI node, that node essentially blocks waiting for that request to be satisfiable, which is fine for a while. But at some point that becomes, at a certain level of scale, that becomes very resource inefficient when you could actually pack many such requests onto, one Spinnaker VM that's doing that work, and just waiting for the cloud provider to make resources available and so forth. So it was just kind of like moving that blocking over to somewhere else.
Mm-hmm. Sounds to me like a mix of CloudFormation, code build, and code pipeline, but cloud agnostic. So right now I would use CloudFormation, to maintain the state, or I'm using CDK right now. Actually, it's the reason why I ask you to postpone the recording, because there are lots of stuff to do. So I'm using CDK with Java right now, and this is state management, and Meta with CDK with Java, I'm provisioning code pipelines and code builds. Right. But I don't even try to be cloud agnostic. So on Azure, I would use Bicep and the attempt, to use both at the same time. Hard stuff. So, but I think with Netflix, they are operating at scale, which makes sense. But I think
exactly
none of my clients needs that actually. And funny enough, so what
I agree. I mean, it's you don't need it for everybody. It's certain kinds of things, So
no, but we know what happened. If Netflix and Google, they are a Java 1, and they present a Spinnaker. So what happens then? In an enterprise project with one EC2, they would try to use Spinnaker because it's cool, right? So this is what this is the effect of conferences.
Yeah.
But
definitely,
that's actually makes sense to me, and now I understand maybe a little bit why Micrometer was needed, to see what was the status of the server, I think, right? Because to feed back the observability part back to Spinnaker. But was it implemented in Java, or what was it, the Spinnaker thing?
Yeah, originally it was written in Groovy.
Of course.
Mm-hmm. And over time kind of migrated more and more towards Java and then Kotlin. And I don't know what the full state of the proportion of which to which language is anymore, but
JVM based.
I think that JVM based, it's it's a series of microservices. I don't know, 5 or 6 microservices together that form that platform. So interestingly, it's not always about scale. At Modern right now, we do single tenant SaaS in the cloud provider and region of our customer's choice. And when I think about but we run it, but in an isolated VPC for each customer. And so our use case we actually use it today is for a particular microservice. We want to see that microservices state in every customer tenant, but that could be spanning multiple cloud providers. So somebody's in Azure Canada, somebody's in US East 1, AWS, somebody's in Switzerland, and I just want to see the state of that microservice across all of them. But so if you had that kind of multi-cloud delivery mechanism for that reason, because it's important to a customer because they have an Azure relationship or something like that.
So you're using Spinnaker right now
comes in.
for OpenRewrite?
We still are for Modern,
but that's pretty cool. So, but are you also using this for deployment and infrastructure as code, or just for the monitor?
It's deployment, So really where the dividing line is our our CI ends at the production of a Docker image and the storage of that Docker image in a Docker registry, and then the first step, Spinnaker pipelines have triggers, and the trigger is a new image arriving in the Docker registry, and that kicks off the pipeline, which then provisions a new server group, waits for enough instances to be up, does zero downtime deployment, tears down the other thing, so on and so forth.
So you're not using code deploy, so you're using this Spinnaker thing.
Right, because it's then cloud neutral for us. We use the same pipeline regardless of whether or not it's in
But you're using
Azure,
CloudFormation on AWS or Terraform?
No.
SDKs?
A little bit of Terraform to establish the VPC. So just to set up the security groups, establish that VPC initially, but that's a one-time operation. And then microservice deployments are affected with Spinnaker, both initially and on an ongoing basis.
So they're orchestrating Kubernetes or Fargate, or what are you using?
We controversially use VM-based deployments everywhere, and not Kubernetes, not Fargate, but rather EC2, which is it's an interesting topic in its own right, but we have a way of capacity planning effectively our needs, and it's cheaper for us to use reserve capacity up to the maximum capacity plan than it would be to sort of scale into max capacity.
Absolutely. Because if you can utilize the machines, it is cheaper than serverless and whatever you have. Because
and even when they're underutilized, just that reserve capacity is just cheaper in some ways. So,
and have you also considered to use Spot instances?
I'm trying to remember. I think it complicates the deployment.
Yes,
I think ultimately
because you have I think 5 minutes time to go away until they are shut down, but it could be even cheaper than the regular one.
There's also some really weird behaviors there. Like GCP, for example, doesn't really have Spot. It doesn't have an equivalent to Spot instances, but it has what do they call it? It's kind of like preemptible instances is what they call it in GCP. Not exactly Spot, but similar in some respects. And their characteristics can be very different. A Spot instance in EC2 survives until you get outbid, right, on the spot market. But a cluster of preemptible instances in GCP gets synchronously killed at exactly the 24-hour boundary upon which it was instantiated.
Okay.
Which to me has always been insane, right? Like I'm okay with any given instance dying at any given moment. That's the nature of operating in the cloud, unreliable infrastructure, so forth. But like to have a synchronous killing of all the instances at once is a strange opinion, I think, to foist upon the mechanism of preemptible instances in GCP.
Maybe that they are intended to have a batch-like behavior, that you have.
I think that's the opinion, right? Yeah. So they have a particular use case in mind, and then if you're outside of that, then you're just not supposed to use them.
So you are the first multi-cloud use case, actually, because what happens in my projects, right? So the enterprises would like to be multi-cloud, and they try and they use, for instance, Terraform and hope this is multi-cloud. It's okay, there's nothing. This is so different. You have nothing.
Right. Totally.
And the networking is also challenging. So you need the operation center somewhere, and you have to talk to multiple clouds. So you need direct connect on AWS. You need express route somewhere else, right? So you have the entire infrastructure. It's crazy.
Yeah. So the networking, the security, all that stuff is kind of set up through Terraform and some other configuration. But then the deployment of microservices inside that VPC, once established, is performed by Spinnaker.
Wow, you have a proper SaaS product, actually, right? This is not bad.
We do. Yeah. So it's SaaS, but it's almost like there's not a word for this, but it's single tenant SaaS in a cloud provider region of their choice. I don't know how common that is, but it's essential, I think, for enterprise to me, especially since we're dealing with code. Having an isolated environment like that.
So this is complete digression, actually, from our topic again. But what I'm doing right now is there's a multi-tenancy, right? But the multi-tenancy is a little bit problematic because if you have multi-tenant environment, you have to have really code reviews and units, because there's always a tenant ID if you do something wrong and stuff like that. But in the cloud and automation, so what we do actually more and more is the siloed tenant. So means instead of having multi-tenancy, we have a multi-account strategy. So we have completely independent, accounts for clients, and it scales very good. But I mean, the multi-tenancy security,
It's
but
similar.
yeah, but what also cool is, right, in such an environment, you have the very easy monitoring, because you are in an account, you see what happens there.
Right.
And if you have a multi-tenant environment, it is really hard to monitor
That's
security,
right.
everything
To
is hard.
separate out.
And this is really
Yeah.
simple, because you are alone, on a server, and this is just, and even the code is way simpler. All the queries, everything,
That's right.
we wire buckets.
Exactly.
We use to exactly one DynamoDB
Right.
table. We can eliminate one.
That's right.
Yeah, and this is, yeah, and
worth
we
it.
automate everything with CDK on AWS, and in multiple projects actually.
Makes sense.
And I got I had also chat with AWS. It's like, yeah, but this is complicated. It's like, yeah, but I mean, if you code the entire infrastructure, it just works. You can use EventBridge, to automate stuff, and interesting.
Absolutely.
So, yeah. So you are using Spinnaker, okay? And Spinnaker is used a lot, or we said it was. I mean, is it still a thing, or it died? Or what's the problem with Spinnaker?
I think so. Over time, the history of it. Originally, Netflix open sourced it. Apache licensed it, and there was then participation from Google writing the Google Cloud Provider implementation, and Microsoft writing the Microsoft. There was an Oracle implementation. There's an IBM implementation. So they got good participation. Although, I'd say, Google fully staffed that team for a while. Others kind of came and went at different times. I think just over time, Netflix withdrew from open source and started doing a more internal modification on it. So I think I don't know all the reasons why. There was a company at one point called Armory that existed really to try to commercialize Spinnaker, but that was recently acquired by Harness, and so I think it's kind of ceased to exist. I don't know what they intend to do with the product line, but I think, like any enterprise software, it continues to exist in places where it was. Some large enterprises do have it internally, but I would say I'm uncertain. I'm uncertain about its future, and we understand that even for ourselves as a risk that at some point, we'll have to think of an alternative multi-cloud delivery solution.
I take a look right now at the commits, and the last commit was 3 years ago.
I think it may depend on, was that on Spinnaker?
Yes.
Because that's kind of just a top level project, but the individual microservices are under, so if you look at Spinnaker Cloud Driver, for instance, the last commit was an hour ago. A lot of there is, so I'd say last week there was actually a bug fix in GCP around health checks for GCP accounts. So there is work still on it. I think largely at this point, it's probably that commit activity has transitioned to the set of commercial customers or enterprises that use Spinnaker internally.
I actually never saw that in enterprise in Europe. So this was interesting. So
that may not be that I would be surprised.
Yeah.
So we had a little bit of it in the UK. Folks we used to work with, but I don't know in continental Europe if anybody that did.
Interestingly, OpenRewrite rewrite has 3 times more stars than Spinnaker.
Yeah, but again, it's kind of it's kind of dispersed because Cloud Driver, Spinnaker Cloud Driver is 420. Yeah, so I guess that's about right. Yeah.
So the last commit, the bot was Mergify bot, but the Spinnaker bot did the commits. But if the true contribution were by developers were 2 years ago, so there's not a lot of activity. There's a little bit,
I think again the primary microservice where a lot of the work is done is called Cloud Driver.
Yeah,
so that would
Cloud
be
Driver
under
right now.
Spinnaker. Yeah, so that's that. I think there's that one last week from Christos Sarvanitis. Relaxed health checks, but there are going to be bug fixes and things that are probably related to just changes in the cloud provider itself.
But I thought this is more popular. Interesting. So
I don't think it ever reached its potential. And in my view, I don't know how true this is in general. I think that Google has always pursued this like a commoditize your complement model, and Kubernetes was one of those efforts, I think. And I think kind of Kubernetes came in at a time and kind of made this promise that you had a cloud neutral platform in which to build, which I don't think is in the same way that Terraform isn't really cloud neutral. I don't think Kubernetes really is either, and most folks discovered that. But it did definitely take a lot of energy and
yeah. I wouldn't even consider
passion away from the project.
Kubernetes being cloud native. I have to say, this is it is like this is
Yeah.
own
Yeah,
cloud,
yeah.
and
It's
from
its
my
own thing.
perspective, it doesn't
Yeah.
make any sense to run Kubernetes on a public cloud. It makes perfect sense to
Yeah.
to build your own cloud with Kubernetes on premise. But
Right.
to install Kubernetes on Azure or it does make sense. Maybe in GCP a little bit, but on I don't know. Yeah. So interesting. So,
Yeah.
but were you involved with Spinnaker? So you committed also? Or?
I was.
Okay.
I was not while I was at Netflix, but ultimately, while working for Pivotal, I was working for the Spring team, and that's where we'll come to the Micrometer bit. But the first step was really Micrometer. The second bit was Spinnaker.
Okay.
The thinking at the time was really that Pivotal would invest in Spinnaker as a part of its PaaS offering, Cloud Foundry. And just offer that kind of higher level delivery experience to its customers. But then again, times changed, and Pivotal acquired Heptio, the Kubernetes founders, and it made like a really hard pivot to all Kubernetes for a time. And so that project got abandoned inside of Pivotal as well. So for a time, yeah, inside of Pivotal, that was the product direction.
So, and why you started Micrometer?
So that goes back, I think, to, and I would give some history here and some of the design decisions that, so, I actually was working for a small insurance company initially and then went to Netflix, and there were a couple things that were pretty shocking to me there. One, that there was a pretty low degree of unit testing or testing in general because of the deference to runtime guardrails, including its telemetry and automated canary analysis and fallbacks and so forth. And so it was just viewed as more efficient, I think, to do that. You weren't paying the opportunity costs of writing tests at any rate. So Netflix had developed that skill in monitoring. There was one particular person that worked on the team, Brian Harrington, that wrote Netflix Atlas, their internal monitoring system, a library called Servo. And then after a certain number of years, and doing a lot of this practice, they learned some things from Servo and basically in some ways started over and did a new one called Spectator. Spectator itself was an instrumentation library for metrics. At this time, and I don't know what the current state is, at this time, Netflix did not do really distributed tracing at all. There were some logs, but they were heavily based on metrics, and a lot of the operationalization was built around that. So Spectator itself was a dimensional metrics library. You could add tags, key value pairs tags to metrics that would allow you to carve up a metric by different dimensions. And some of those tags were related directly, although it wouldn't have to be this way, it was by convention. Some of those tags were related directly to those Spinnaker concepts I was mentioning before: instance, server group, cluster, application, region, etc. So when you were looking at a monitoring system and you got an alert for something, you could explode by one of these dimensions, locate a particular instance potentially, and there was an action path. You could go to Spinnaker, identify that little green chiclet that represented that thing, and actually take an action on it, take it out of the load balancer, kill it, restart it, something, So it was really like tying these two, the stateful representation of your assets with the monitoring on the other side of it. And so, of course, you needed a dimensional monitoring system for that. I was looking when I went to, go to the Spring team. Spring was entirely lacking really a metric system. There was a hierarchical metric system that was more like, I don't know, it was a very, very, very primitive thing. So no tags, no tag key value pairs, variable instrumentation throughout. It really wasn't, Spring didn't see operational reliability as one of their responsibilities. And so I came in part to do that. When we thought, okay, we want to add this, we want to basically take the skill set that Netflix had there and bring it to the Java ecosystem as a whole. At that time in 2017, I guess, there was no open telemetry. There was something called Open Census, but it was very early and did not have a GA release. There was Prometheus client, which was dimensional, but it was specific to Prometheus. There was vendor-specific metrics instrumentation libraries, a Datadog client, this and that. But there was not really a like SLF or J for metrics, like a vendor-neutral abstraction for that. And I actually looked heavily at Spectator because Spectator itself from Netflix was a vendor-neutral abstraction, but it hadn't gone far enough in certain ways, and we could get into details on that. So I talked to Brian, I talked to the Netflix team about, what is their willingness to kind of expand Spectator to the needs of other monitoring systems that Netflix wasn't using internally, and they just didn't have the resources or didn't have the interest in doing that. And so we kind of mutually agreed that there would be a very Spectator-like thing that came out but was distinct and that answered the concerns of these other monitoring systems that didn't resemble Atlas internally. And so it started in Spring, but the idea was, of course, always to put first-party metrics instrumentation into libraries up and down the stack, like RabbitMQ client, and also the application, so that you got more coverage in very much the same way that you do with like SLF or J logging. And I did not, the very, very, very first incarnation of it was called Spring Metrics. And an engineer by the name of Clint Checkett said, take the word Spring off of it. It doesn't have anything to do with Spring, right? It's independent of that, which was honestly one of the better decisions. So I started pursuing, working more closely with the Quarkus team at Red Hat, the Micrometer team at Oracle, et cetera, to provide kind of one basis for us all to write our metrics on. And so I think it was just very fit to that particular point in time. So we can get into more specifics about maybe why certain design decisions were made, but that was the genesis of it.
What is your first line of code? You remember how you started with Micrometer?
In that library.
Yeah, Micrometer or Spring Metrics or whatever it was called at the beginning.
I think I had a lot of admiration for a lot of what Spectator learned, right? And one of the things, and to just give an easy example of this, Spectator had metrics. I'm going to say metrics from the perspective of the application developer recording something, not time series in the sense of like rows that show up in a time series database, but metrics in the sense of like, what am I interacting with as an application developer? So they had metrics for gauge, like a speedometer, that's gauge, a counter, a timer, a distribution summary. They called it a distribution summary. And so like, just take timer for a moment. A timer in Spectator's sense actually was composed of multiple lower level metrics. It was a counter for the total latency induced over a period of time, a counter for the number of occurrences of something. So you could take the sum of all latency divided by the count and get an average throughput. It had percentile approximations built into it, et cetera. And so a timer was like this concept of like creating a higher level thing for like a application developer to use to record a metric, but that actually resulted in many time series showing up on the other side. And so I just took those as is because those had been learned over a long period of time. So that was
reminds
the
me of
point.
timed. I think in Micrometer Metrics was timed, right? The annotation. This is the.
That's right. That's right. And so, but interestingly, I think that's one of the things is like, they had learned that, and annotation was not ideal in many cases, because in too many cases you wanted a tag to be on that metric that was sent that relied on variable state inside of the body of the timed thing.
Mhm.
So if you want to record a tag, for example, in unsuccessful, outcomes just on the exception name of the exception that was thrown, that's not accessible from an annotation. So again, very, very heavily inspired by, or just downright copied. That was the starting point from Spectator.
You're right. I heard it often that it's not enough, but I mean, in my projects, what we did. So the problem is then that in enterprise projects, large companies, actually no one cares about monitoring because it is not rewarded.
Yeah.
So imagine, large projects, many external companies, developers, and they do whatever they get rewarded, or it's what is measured. And the only thing which is measured in large companies is, sadly, unit test coverage, right? So at least is my observation. So they have they invoke all getters and setters to get high code coverage, and the observability is forgotten. So in such a project, what I did, I use heavily annotations on the, I call it boundaries, on the outside. So so the idea was, if you put some annotations on the boundary of the microservices, and if you have I/O to other services, so if you call other services, you also annotate the interfaces. This was Micrometer REST client, for instance. And with that, I would say there was almost nothing to do, and we get somehow, decent monitoring. And the next step, which was not always achieved, because, then the developer said, okay, it is already monitored, we are done. But what I also wanted to have, we could inject the metrics registry with Micrometer REST client, and then have internal counter. And what I wanted to have, just a simple counter. So for the essential use cases, how often something got sold, or whatever. So what was essential to the project, and maybe I counter what went wrong. And with the two counters already, you could have an average over time, so you get a pretty good feeling, whether your application is working. So this was actually my 80%, which I wanted to achieve. And then Micrometer happened, and they say, you could, this data tag or whatever. I was like, what are you talking about? I mean, this is like, if we do introduce this, nothing will happen, because without the annotations, no one will code, metrics inside the code. And if you have business metrics, it's also hard somehow, to attach them to a method without coding. So you need AOP or some patterns. So we could do this in consistent architectures. So this is why I had lots of discussions regarding annotations and how it should happen. I think Micrometer, is a pretty cool implementation which could use internally, and on demand you can still use the annotations. So I think there will be Quarkus job or Helidon or Micronaut, to have the MP annotations, and behind the scenes Micrometer is used, because because
as it turns out, actually, Micrometer also introduced the same annotations. They were just in a different package. So the same timed annotation, counted annotation, et cetera, existed in Micrometer as an alternative mechanism for exactly the reason you're describing. And those were quite popular in their own way. But so we tried to accommodate different styles and not be idealistic about it. So annotated versus inlined into the code, etc., were both supported. But
it's interesting, where like different cultures maybe. If you build a product, you can invest more, in observability, because you have to live longer. But in projects, no one cares maybe, and they just put the annotation on the methods and they
test coverage.
Yeah, maybe.
Absolutely. Yeah. And it's, so putting the annotation gets you somewhere.
Yeah.
We don't have to strive for perfection. I totally get it. So that was it's just like a compromise to practicality that I think was a hallmark of trying that approach.
What you are doing in your Moderna implementation, I guess it's written in Java, right? Your backend, hopefully.
It is.
So you're using annotations, or you're coding, metrics inside, or you do nothing.
We do write the metric, although even in this situation, like some of the microservices use reactor or reactive streams, and so the metric actually winds up being either a hook on the stream itself. Mm-hmm. So it's kind of like in the same respect you say AOP, kind of do it centrally. It's kind of done centrally. In our case, and so to speak about culture, it's you echoed what, but I was thinking earlier as well, is that unit test coverage versus observability is really interesting, right? So Netflix had very low unit test coverage, which was a shock to me, very high observability. And you see the opposite as well. In Modern's culture, as you can imagine, very high observability. Unit tests were practical. So OpenRewrite is covered with quite a bit of unit tests. The services themselves, less so, because again, there's the safety guards in production. And so because metrics information is so essential to how we operate it, it's just part of what it means to be an engineer here. And they add rich tags to these things.
Yeah, very good.
And so I guess the training of the engineer here prevents the problem of they don't care about adding business metrics.
What we do a lot, I call it system tests. There's no good name for it, or end-to-end tests. So where we are testing the API from outside, right? So and so we have like in the pipeline, so we call all the APIs. The problem in larger companies is it's not measured, so they don't like it because at the end of the day, they don't get the code coverage for system tests. You could do this with Jacoco, but it requires additional setup, which is, so okay, we don't do this, we just run the unit test. But it changes a little bit in smaller projects. In larger projects, still unit tests are the king. Okay, interesting. So
absolutely.
Yeah.
Absolutely.
So and you got the experience from Spectator, right? So this was what
I did.
Yeah. So you worked a lot with Spectator and in production, and it's okay, what worked and what didn't, and then I say just rewrite the Spectator and a Spectator and do it better, right?
Yeah, do it, but I mean better in one sense and not in another. I mean, I think that to me the like metric abstractions were pretty good, counter timer gauge, etc. Distribution summary was really interesting, but and so there were few shortcomings early on, I feel like, and one of them was a really bizarre thing in a way, which is naming convention. Mm-hmm. And the initial implementations, back-end implementations of Micrometer were Datadog. Even we were flattening dimensional metrics onto hierarchical metrics like graphite, just so that you could ship the two monitoring systems. You could basically like maintain your state over here while you transition to a dimensional one. Again, radical practicality here. But we had Signal FX at the time while that still existed, Wavefront while that still existed, Splunk, like also whatever. There's a number of different monitoring systems, Prometheus. And when I got to the point of thinking about like when you have different words in a metric name, like I don't know, API dot something or whatever, like, should it be dot separated? Should it be camel cased? Should it be underscore snake cased? And I looked at a population of production monitoring systems and tried to see what the common denominator was on them, and found surprisingly that they were mutually exclusive. So for example, in Signal FX, you had to dot separate things because the UI showed metrics in this tree view based on dot separation. But I don't remember which one it was, like graphite, one of them would just blow up if there was a dot in the metric name. And so there's this weird, like, so what do we name like metrics like in the code? Because there's these mutually exclusive decisions. And so really early on, Micrometer introduced the concept of naming convention normalization, which is that you use a dot separated name, and then when it's attached to a registry, the registry itself massages the name to look idiomatically consistent for the context of the back.
Okay. This is one of the killer use cases, right? So that the name can be like name abstraction. So you have a logical name, which is then translated to a physical name. Which reminds me of AWS.
And so there were some weird things too. Like sometimes it was like suffixed, like Prometheus, for example, a timer, like what was his name? Brian Brazil, the Prometheus author, had this really opinionated, like, I want to have the unit name on the end of the timer seconds count or whatever like that. And so the naming convention normalization would append unit suffixes to the end of a metric name as well, which were not idiomatic in other monitoring systems. It's just really bizarre things like that.
What interests me, Prometheus does scraping, right? If it scrapes, for instance,
I know.
and you implement the averages, it is for Prometheus a little bit problematic because some of the probes can get lost and then you cannot recalculate anything. So is Micrometer for scraping?
So we don't do averages.
Exactly.
I mean, the timer that goes to Prometheus is a count, a sum, and a max.
Okay.
A rolling max. So from this, you can divide the sum over count for a particular dimension and arrive at the average. And that was like, and there were a lot of metrics instrumentation libraries prior to that pre-computed average.
Exactly.
And like you say, averages are not dimensionally aggregable across, like anything. It's meaningless.
So in Micrometer, there are no averages. It just exposes the...
It never, except, and again, radical practicality. So, for example, graphite had no query language with which to divide sum over count. And so for graphite, as primitive of a system as that was, when you recorded a timer, it would ship a count, a sum, an average, a max.
Okay.
But for Prometheus, knowing that Prometheus had the query language PromQL on the other side, we would ship a sum, a count, max. And so these are like these weird you want the programmer's interface to a timer to be the same, but how it shows up on the other end is registry specific.
So sounds like last mile, right? You did everything, and then the last mile, to see how you actually expose the thing. Yeah, okay. This is what I understand.
Another really interesting element of actually mutually conflicting opinion here is the expected base unit of a time latency, for example. So Netflix Atlas expects timers to be in nanoseconds, always. And Prometheus expects timers to be in seconds, always. And there were other systems that expected milliseconds. And so from a programmer's perspective, you just record the timing. How I'm keeping that data for the sake of shipping it to the monitoring system is registry specific to the time dimension of that system.
Are there adapters around the repository? So if I have Prometheus, I get the Prometheus data as almost a decorator, right? Or how you would call it?
It is. Yeah, so it's a registry implementation. It's a back-end implementation. And you could attach multiple registries to an application at any given time. So for one timer from the programmer's perspective, it could be stored in memory temporarily in seconds for Prometheus and nanoseconds for Atlas. And then Atlas is pushing metrics and Prometheus is pulling metrics. But from the programmer's perspective, I just did a timer. I don't really care about any of these other things.
So what is the architecture of Micrometer internally? So, what components Micrometer has or comes with?
I can speak more to what it used to be.
Yeah.
And I think to the extent that it was a metrics instrumentation library, I think the main things programmers were dealing with were metric types, meter types, we called them, which are again, counter, gauge, distribution summary, timer, and their variations. And then the registries themselves.
What is distribution summary? What is distribution summary?
Yeah, distribution summary is it's actually a corollary of a timer, but not dimensioned in time. And so, for example, distribution summaries are often used for payload size in bytes.
Oh, okay.
And so for a payload size in bytes, I would want to record once for any particular payload that came in, the bytes that I saw on that payload. And the distribution summary would record a count of the number of those payloads I received, a sum, just like we did for timers, of the size of all bytes combined, a rolling max of the maximum byte size that I saw. And then, of course, you can divide sum by count on the back end and get the average payload size. So it's very, very, very similar to a timer. But the key difference there is that there's no base unit of time normalization, because the base unit in this case is something like bytes or people or money or something that
sounds to me like a mix of timer and gauge, right? Gauge provides the payload information, the size and counter, or no timer, counter and gauge.
It's a compositional relationship. So a distribution summary records a gauge for the max, which rolls. It goes up or down over time. A sum, which is a counter, and an account, which is a counter. So it's two counters and a gauge by default. And then on a distribution summary, you could configure additional options, which are like SLO boundaries that you want to record, percentile histograms that you want to record, etc. And those were optional additional time series that would come out of that one construct once it was created.
So this will be the third step, have something like this, because if you know, you could configure it for your business needs and get something meaningful, right? So for instance, so this is absolutely. Yeah. So okay.
And so we do that all the time. In the case of like OpenRewrite, we will record a distribution summary when we run a recipe. We will record a distribution summary for the total number of source files in a repository, or the weight of all LST elements in a repository. And then I can correlate, I can have a chart, which is like distribution summary. How lumpy was the repository that was running? And what is the corresponding latency of the recipe run? So that distribution summary and timer are closely related.
Well, this is already business metrics. This is almost like analytics.
It is.
Yeah.
It is. It really is.
Yeah.
It really is.
But it's still in memory, right? Or you can persist the metrics with...
And that's just it. It's in memory until it gets either pushed or pulled from the monitoring system. Okay. And then the monitoring system becomes that stateful representation of this metric for as long as you wish to retain it there.
So it was always designed to not be the monitoring system. So not like, there's like... So
exactly. That's true. That's an important thing to say, actually. Not a monitoring system. Just... very much like SLF or J, but for metrics, right? Not a logging system, just wiring to one.
And what are you doing? Are you using Prometheus and Grafana in your case, or as a monitoring system?
We are.
Okay.
Yeah. And so we talked about individual VPCs, right? So like single tenant SaaS, cloud provider region customer report. So actually each SaaS tenant has its own Prometheus, and own Grafana. And we actually give customers access to that. So they can see all the guts of how their thing is performing. If they want to, it's up to them. And then we have one federated Prometheus that pulls from every one of those, individual customer tenants, and one Grafana. And so when I look at a dashboard, an operational dashboard for me, I've got tiles at the top or drop downs at the top where I can select for a particular chart. I can say which customer, which region, which cluster, which version, which instance, which, and drill down into something.
Yeah, great system you built. What I like the idea that you use actually EC2. So because usually, so I'm speaking at conferences from time to time, and usually I always talk about serverless because serverless for enterprise project makes absolute sense. But what you should know, right? That serverless is actually more expensive than EC2. Of course, there's no added value,
Absolutely.
and this is 20-30% more expensive. And it only makes sense, if your application not active all the time. So, for most enterprise project is great because they work, from 9 to 5, and then nothing happens at night, and there are vacations. So most of my serverless projects are cost almost nothing or little, right? So, and I always say, but for specific use cases, I would just go with EC2 or even, bare metal, more or less. I mean, the virtual machine is a virtual machine, but it's more or less bare metal. And now I have a use case, This is now recorded on the podcast. I say, okay, look, the OpenRewrite or Moderna, they actually have the use case and can save money with EC2, which is because it's always good to have another example, right? So in my world, serverless makes sense for enterprise, but if you build a system, which is like 24/7 in your case, so there's always traffic, right?
Yeah, always 24/7. But we talked about the deployment pipelines earlier. We do set. We don't have to, but for most of our customers, we set availability windows. And so when I do a deployment, when I do a CI build that does a release of a microservice, it produces a Docker image, which triggers each of the pipelines for each of the individual customer tenants. And one of the stages in the pipeline basically blocks it until that time window is reached. And so a service will roll out, that update will roll out immediately to the public app tenant, where we run about 3 billion lines of open source code. But it'll get blocked for the customers until basically they are end of business, and then it immediately rolls out to them as well. So situational, depending on the,
Then just a question regarding deployment with Spinnaker. So if you use just Terraform or CloudFormation, whatever, and use VPCs and IP addresses and networks, so the NAT gateways and DNS can be sometimes tricky. And I mean, Spinnaker cannot solve the problem because you get the same problem if you use CloudFormation CDK or Terraform, which is the AWS API. You have some lookups problems as well, or it works everything smoothly always,
Like microservice to microservice lookup?
No, if you provision the infrastructure. So you have to provision NAT gateways, load balancers, and this can be nasty, because then there are some relations I remember. So right now I just do mostly serverless. There are no VPCs, but I did a lot with VPCs, and there was always no problem. You have to, if the NAT gateway, and what was the problem? There was you couldn't delete easily NAT gateway if there's IP address attached or whatever. There are some dependencies,
You're right,
which are really hard.
You can't delete a load balancer.
Yeah.
So in our case, like load balancers, NAT gateways, security groups, this sort of things are part of the VPC provisioning, which is Terraform driven, sort of. There's also some.
It happens once, right?
One-time Spinnaker steps there as well. It happens once.
Oh, okay.
Yeah, and so a particular load balancer in that Spinnaker abstraction of a cluster, you've got multiple server groups, which in the case of AWS is an application server group or ASG. In the case of Azure, the VMSS or virtual machine scale set, I think it's called. At any rate, a collection of instances. And what's interesting that doesn't really exist at the AWS level is a group of those server groups.
Mm-hmm.
There's not a concept for a group of server groups of different versions. They don't prevent you. It's just not. There's no structure for that. So in Spinnaker, there is structure for that. You see different version server groups, and that load balancer gets put on one of those at any given time. So we do Spinnaker reuses the load balancer to direct its traffic to one or the other server groups, depending on which.
You are lucky because you do it only once. In my project, in infrastructure as code, if something changed, we re-provision the entire thing, and then the lockups happened. This was something.
And then Terraform does some things.
Yeah, exactly. Then we have sometimes add additional dependencies, and
yeah, exactly. That makes sense.
Okay.
Yeah.
By the way, IBM bought HashiCorp and also Terraform, right? So also interesting.
I saw that. Yeah.
What happens because they have Ansible and the others. Really interesting what happens to Terraform because IBM has also Ansible and something two tools, right? Ansible and what is the second one? Infrastructure as code.
They also have Puppet.
I think Ansible, Puppet. Something like this, right?
I'm not sure who has what.
Okay, so. Back to Micrometer. So we have the registry, and you can push the registry via annotations, or you can use the API, right, from Micrometer to set the counters, or how to call it, to create the metrics, basically.
Yeah.
How to call
and
it?
So even there, there was a really early tension between should the registry be dependency injected in the IOC sense, or should it be statically or should there be a static registry to which those registries are attached in the SLF4J form? And I wrestled with this for a while because here in a Spring team, very dependency injection heavy, but I wasn't sure that was clearly the right opinion all the time. And so it provides both.
Oh.
And you can use both in one application if you wish. I think there's a really interesting practical element there, which is if I'm the RabbitMQ author, for example, RabbitMQ client library author, I can't do dependency injection for metrics because that would expose my metrics registry in my public API signature inadvertently. So it's better for the library to use the static registry, and if there happens to be something attached to the global registry, those metrics stream out. If they aren't, they don't. It just gets sinkholed otherwise. But then in an application, sometimes people want to unit test their metrics, which I don't really favor, but I've seen that. And in that case, they want to do dependency injection. So, you can do both if you wish.
Yeah, I think the advantage of dependency injection is I don't know about Spring, but in Quarkus you could use the producers in the injection point, so you know where it is injected, so you can add additional data to the registry and say, okay, look, this you are already in the class, and then this is what would be the advantage. But I would be in favor of static registry without dependency injection because not needed.
That's what I've done.
Yeah, because if you are, you can build your CLI tools in Java, whatever. It will always the same approach.
Absolutely.
There's not. Yeah,
absolutely.
Mm-hmm.
But it's interesting in that, again, this was just like trying to be a peacemaker. Like, mm-hmm. I feel that way. I use a static registry, like every time.
Yeah.
I don't unit test my metrics. I think that's kind of weird. But who am I to say what's right and wrong? And so I'm just not going to be opinionated about it. Maybe very anti-Spring in that way, to be honest with you. I was kind of like against the current a bit because I just thought, whatever makes sense for a particular application team.
Yeah, but regarding unit tests and metrics, so I don't think I would test metrics, but what you mentioned with your OpenRewrite metrics, there's a bigger thing, right? You are measuring the LSMs, right?
LSTs.
LSTs, sorry. The LSTs.
Lossless magic trees.
The LSTs and the and something else. You said the amount of source code was scanned, I think, what I remember, right? But this, at least, I will put some, I will ask the gauge to give me the data, put the metric, and see whether it is reasonable what comes out, right? So this minimal thing I would do, actually.
Yeah. There very well may be cases where the easiest way to test a pile of functionality is to test the metric.
Yeah, but I wouldn't use dependency injection for it either. You could still...
Agreed.
Yeah,
you couldn't. Yeah,
the dependency injection doesn't matter at all. Because
you may have the static state problem then. You may have the static state problem of like parallelized test runs and static state and all that kind of stuff. But
But I could clear the registry, no? It's not possible to clear it?
You could, but then you run into the situation again with statics where you have parallel tests running and, I don't know, those kinds of situations where it can get problematic.
I see. Okay, this could be problematic, but I could create a new one or whatever, right? So it's not possible that I can say...
If you happen to be running their tests in such a way that they would share a class loader, like unit tests would share a class loader parallelized, then you have that.
But I'm with you. This is a small thing, and what I do in serverless environments anyway, what I do even worse, I have to admit here on the podcast. So I have, the Frizzle layer in Quarkus, usually JAX-RS. And if there is some trivial code, I write an interface. I have an interface with a static method, with the procedural logic, and I'm done. So, and then I don't have dependency injection, no new. I just say, interface dot something, and it works. And there are no problems. And if there are problems, of course, then I create a class. Then I can eject the class still. But such a simple static interface is very easy to test. And I had a long discussion, not that long, but there was no say, okay, you are misusing interfaces. Like, yeah, but it works. Who cares, right? I mean, it's just
if it's elegant looking. I mean, after all, code is somewhat of an art, right? I think it makes sense, especially in the serverless case. That's what's so interesting is it's like that pattern is tied to that deployment methodology.
Okay, so we covered now the registry, and it can be static or injectable. We said, okay, static is like singleton basically with all the metrics, right?
That's right.
Okay,
that's right.
And then we have exporters and how to call it. So which export the data from metrics to Datadog, for instance.
Yeah, and so those are called registries. So exporters themselves are registries. That's an implementation. So meter registry is the interface by which you could register a counter in the abstract sense, or a timer or whatever. And Prometheus meter registry is the Prometheus exporter for that. Datadog meter registry is the exporter for that.
But I could have multiple registry at the same time, right?
Absolutely.
With the same data.
And you could even have multiple registries of the same type. You could have two Prometheus meter registries.
For distribution summary of your LST. I could have a LST metric in two registries exported at the same time, the same metrics, so Prometheus and Datadog. That's
right.
So then the registry is, for me, a bit misleading maybe. So what I'm missing is then the store. So then we have a store in the middle, which is a singleton. And then the registries are picking the data from the store, right? It's just the registry are just a view to the data.
No, because the store of the data is actually specific to the registry, right? That's where we went back and said, for example, Atlas uses rate normalized metrics
Yeah.
Prometheus uses cumulative metrics. Atlas wants nanosecond times.
Yeah.
Datadog or Prometheus wants second window times. So each registry actually, stores the data internally in its own way, using its whatever mechanism.
What I
makes sense to
thought,
it.
you have a kind of a meta model, which is monitoring tool agnostic, and then the exporters would just read, the meta model and transform it to the right format. So, but the data is already pre-calculated for the proper monitoring solution, right?
Exactly. Yeah.
So
exactly.
I would have to write to two registries at the same time, right? So, or use two registries. It could be transparent, but at the end, my metric would be in two singletons at the same time.
Only one. So you mean if you were exporting to two metric?
Yeah, let's say I have my.
Yes, it would be.
I have a counter.
Yes.
I have a hello world method, which is access from outside get, and I would like to see it in Prometheus and Datadog at the same time. So I would have to configure
two meter registries.
Two registries, and the counter would be in two registries at the same time.
That's right.
Is
and the actual internal representation of it in those registries could be different.
Yeah,
based on the
one could be nanosecond, second, or whatever. Okay, this makes sense. So it's simple.
Absolutely.
So there's actually
in some cases the storage itself is not like there's actually no way to store a vendor neutral implementation and then derive from that the value that's needed. So it's actually very important that the value goes immediate, like the recorded value goes immediately to that registry implementation for temporary storage and however it's
just straightforward design. So basically you have only registries, right? Okay.
Only registries. And when you say singleton, to clarify that, like there could actually be two Prometheus meter registry instances that are unique from one another that though they're of the same type, you could have two of them. So there's nothing to prevent you from having multiple registries of the same type.
Perfect.
So registries themselves, by the way, now registries themselves can be configured with what we call meter filters. And those filters can be used to basically, there's a lot of things that they can do, but in brief summary, they can filter, they could just drop metrics on the floor. They could enrich them with additional tags. They could drop tags. They could rename tags. They could, different things like this. And so this concept actually, while it didn't exist in Spectator, was informed from the very beginning at Micrometer from what I saw at Netflix, which is that vast majority of metrics went to Atlas and a very small set of metrics went to CloudWatch.
Mm-hmm.
And they actually used CloudWatch as a kind of almost like a break glass, like if Atlas goes down, then we at least have something, but it's very coarse grained.
Yeah.
And so interestingly, from the applications developers concerned, you record everything, but you may actually segregate or filter out the population of metrics that arrive at any one of those.
This is basically, I think this is cost driven, because CloudWatch under heavy load would cost a
very
lot.
Expensive.
Yeah.
Very expensive.
Yeah, this is also what I heard, with the microproblematics. Like, hey, you could just pick, Micrometer and write your filters for your. It's like, yeah, but I could, but I don't like to do it in all projects. But now, we have the annotations and the drama settle a little bit. But there's was still interesting to observe. And you are the evil programmer who created Micrometer,
Obviously, yeah. Well, and it's it's interesting now because one thing I think I've had to get used to is I think to be honest, the world's never in a perfect state, and I'm sure that I made incorrect decisions here and there throughout Micrometer as well. I did the best I could, and it was informed by a lot of. It's not like it was my idea; it was informed by a lot of experience previous to me. But now I think there's now open telemetry exists in the GA form, and there's a lot of vendor participation and support behind that. I don't find personally its APIs to be as useful. It lacks these higher level metrics concepts that I find useful. But I think I had to accept that, sometimes we don't wind up in a perfect state, that the predominant effort now is there.
No, I think...
So one thing I thought there were two dimensions of where I felt with Micrometer, there were kind of like two dimensions that I think I could have pursued. metrics registry implementations, like try to support as many as possible, Prometheus, Datadog, et cetera, et cetera, et cetera, but for just Java. And there was the other dimension is language support. And so I deliberately elected to choose for it to be JVM, but provide as many metric registry implementations and richness as possible, knowing full well that, that language support was another interesting dimension of, and so I think OpenTelemetry did the opposite, which is that it went very language agnostic, but its abstractions for metrics didn't reflect the mutually exclusive variability in monitoring systems because they didn't know yet. They were targeting Prometheus and whatever, something. And so they didn't yet see the mutually conflicting opinions that I did see very early on by choosing that other dimension to expand in first. And I think that will be a long-term weakness of it, but you can't do both at the same time.
No,
so
and Micrometer sounds great to me, and now I understand a little bit better your decisions because from complete different angles, right? So in my world, Prometheus was the standard, for instance. And it was almost the first one. And from Prometheus, to my knowledge, it became the first, not OpenTelemetry, but I think the first CNCF standard API. Was OpenTelemetry, right? So it was the first OpenMetrics. Yeah. OpenMetrics, I think, was the name, right? OpenMetrics. And all the projects were Prometheus based, right? So, and if you have such a thing, then, in microprofile metrics, for instance, it was fine because it worked out of the box. And any attempt of configuration or registries was just crazy. It's like, why I should do this if conventional, we have always Prometheus. The next thing, which I really like in microprofile metrics, is the idea that there are like the separation between vendor and application metrics. This was what I really appreciated.
I see.
Because all the application server runtimes, they had a lot of garbage collection and stuff which I was never interested in because there were other possibilities to gather the metrics. I was only interested in business metrics. So what I always did in microprofile, I say metrics/application, and there was my part, and they were already pre-filtered, which was great, right? And in enterprise projects, so also interesting, as we already discussed, the business metrics were often ignored. So what happened then? But the application server metrics were still emitted. So I saw no big projects where they just looked the entire day on garbage collector graph or something which was meaningless. And with the trick with the application, with the pre-filtering maybe, we only expose a subset to Prometheus, but the subset was meaningful. And then there was a discussion. Micrometer is more powerful, and the discussion was, we can support Datadog, and it's like, okay, we could, but no one cares about that. I mean, if you're in the cloud, we can export CloudWatch to Datadog or whatever. But the standard was for me Prometheus, and your angle was completely different. You say, okay, there is no standard. We support as many monitoring systems as possible. So I would say, from the conceptual perspective, Micrometer is way better. From the microprofile metrics perspective, because everything was hard coded and there were less choices, it was very convenient to use without any configuration. It worked in and I got the feedback from many developers that what they really liked is the strict separation between runtime metrics and business metrics. And
interestingly, I effectively do the same thing even with Micrometer, although it's not like an official feature. I'd say in Modern, we just simply prefix business metrics with Modern dot.
Yeah, exactly.
And then,
but
I do that more for convenience because over in Grafana, I just type Modern _, and I'm already only looking at business metrics.
Yeah, but you could do this because you build a product. So in my projects, I have to explain to every client.
Absolutely.
And this is
the same opinion.
Yeah. And back then there was no discussion because already preset. It's like, look, application and forget it. And this was the thing. Okay.
It's it's the first time I've heard this. I never really even considered that distinction. In fact, and before you mentioned this, it's one of those things where Yeah, I wish I had heard it some years ago. But
maybe the difference, Spring had nothing, and the application server had lots of monitoring always. There was I used Glassfish back then for 15 years, and Glassfish exposed everything as a metric. So there was you get out of the box maybe 300, 400 metrics. WebLogic the same. All the application servers are very strong in metrics. But I was only interested in these metrics in task forces or firefighting stuff, and and I wanted to clearly separate these metrics from my metrics, and this is what MicroProfile did perfectly.
Yeah, interesting.
Jonathan, so I think we covered Micrometer completely, right?
Yeah, I think so. At least up to the point where I was involved in it. It's changed since then, ad tracing and things. But
it's
I don't know a lot about that now. Yeah. So.
Perfect. So I wish you.
It's the history of it anyway.
All the best with OpenRewrite on modern.
Thank you.
And what I can tell you, it's just the popularity skyrocketed at least in Europe, in Germany, and it is. In 1 year, I think. So there was a great job you did with the team. So it is now everyone is aware.
I think a lot of that's credit to Tim Tabeek. Yeah, Tim Tabeek and the Netherlands who speaks quite a bit on it. But we've started seeing others pick it up, and that's I'm glad to see that.
Where people can find you? So OpenRewrite, your Moderna, or whatever.
That's right. Yeah, I'm pretty easy to find on LinkedIn, Jonathan Schneider, and then on Twitter, John Jon_K_Schneider. So yeah, either way, DMs are open, and happy to talk anytime.
Thank you a lot.
Okay, thank you, Adam.